Hi and welcome back to the Mr. Talbot Maths video. This week's problem is finding the area of this blue triangle. So as you can see, it's kind of rotated to the right angles at the top, and then we've got this vertical side or line inside our triangle which has got a length of 2, and that splits the hypotenuse of the larger triangle ABD into 2. Now, the way I approach this problem, like with many of my problems, geometry-based problems, is using similar shapes. And basically, what I found is that, well, this angle, if we call this theta, because we've got a right angle in ABD, this must be 90 minus theta. And if we look at the triangle ECD, we're going to have a right angle down here. So this must also be 90 minus theta, or alpha. I don't know why I've called it theta there. 90 minus alpha, alpha, 90 minus alpha, 90 minus alpha. So we've got two similar triangles. You've got ABD and ECD. So if I draw those triangles out, I have got these two triangles down here. And I'm going to label them E, C, and D for the smaller one. So E, C, and D. And then for this larger one, this is going to be A, B, D. So at my right angle, I've got A, on this side is going to be B, and then D over here. Okay. Now the next thing I then want to do is I want to look at some scale factors, and I need to label the triangles. So E to C is going to be a length of 2, and because I've got the hypotenuse of ABD, these sides are equal, so I'm going to call those X because they will be involved in both triangles, which is going to be crucial. Going back to triangle ECD, the base here is going to be X, and then the hypotenuse we don't know because 6 is the length AD. Okay, so going to our larger triangle, AD is 6, and then AB we don't know, but B to D we know is 2X. Now from there, what we can do is we can get a scale factor, which is important. So that scale factor is going to be timesing by 6 over X. And so I can now do that for every side that I've got. So this hypotenuse here to 2x is going to be times by 6 over x, and this 2 to this side is going to be again times by 6 over x. Now 2 times 6 over x is going to give me a length of 12 over x. And if I do 2x divided by 6 over x, if you're dividing, remember you flip your fractions, so essentially we've got 2x divided by 6 over x. That's the same as doing 2x times by x over 6, which gives us x squared, and then we get 2 divided by 6, which is 3. So we get x squared over 3. Okay. Now, from there, what I can do is, because these are right angled triangles, I can also use Pythagoras, which is the key bit, because at the moment they've still all got x's in. So what I'm going to do is I'm going to look at this smaller triangle, CED, and I'm going to do 2 squared plus x squared is equal to x squared over 3 all squared. And the larger triangle, I've got 6 squared plus 12 over x all squared is equal to 2x all squared. Now, as long as I've done this scale factor right, which I should have done, there shouldn't be any difference really with these equations. And actually, if you work either of them through, you will end up with the same thing. So I'm just going to choose one of them at the moment, but we are going to use the other one at the end to check. And that's an important thing that you do when you've got, multiple equations like this. Check that the solutions work in both and there's not two different solutions. There shouldn't be, like I say, but just make sure to check that. So we're going to go with this bottom one. So I'm going to square 6, I'm going to get 36, plus 12 squared is 144 over x squared, and then we get 4x squared here. Make sure you square the 2 as well. Common mistake is people just square the x and forget to square the 2. Okay, now I need to get rid of this denominator of x squared. So I want to times everything in this equation by x squared. So I'm going to get 36 x squared plus 144 is equal to 4x to the power of 4. Now from there, I'm going to get everything onto one side because I need a quadratic, or in this case a quartic, to be equal to 0 to solve it. So 0 is equal to 4x squared minus 36x squared minus 144. 4x to the power of 4, I should say, not 4x squared. Now then what I need to do is, this is what's called a disguised quadratic, because if I let y equal x squared, then this will change into a quadratic in terms of y. So I get 0 is equal to 4y squared minus 36y minus 144. Okay, now the next thing we need to do is divide this all by 4, because these are all multiples of 4, so that's going to make my life a lot easier. Or you could of course use quadratic formula. So dividing everything by 4, I get y squared minus 9y minus half of that is 72, half of that is 36. Now this is quite nice, so I can factorise it. So in brackets y, and I'm going to get minus 12, and then y plus 3 is equal to 0. Okay, so that gives me solutions of y is equal to 12, or y is equal to negative 3. And now if I replace the y back with x squared, I get x squared is equal to 12, or x squared is equal to negative 3. Now x squared is equal to negative 3 gives me no solutions, because you can't square root a negative number. But we can square root of 12, so x is equal to plus or minus square root of 12. X is equal to plus or minus square root of 12. 12 is made up of 4 times by 3, and we can square root the 4, but we can't square root the 3. So we have to leave the 3 inside the square root. Square root of the 4, we get 2, that goes outside. Square root, plus or minus 2 root 3. Now then we need to look back at the question, because actually are both of those solutions possible? And if we scroll back up to the question, past all this working out, x is a length. And so because x is a length, we can't have minus 2 root 3. We can't have a negative value. Right. So x is equal to positive only. So x cannot be negative, as it is a length. Therefore, x is equal to the positive version of 2 root 3. Okay, or we could just write 2 root 3. Now that's not the answer, because the answer is asking about the area of the triangle. Right, so if I quickly sketch out my triangle again, so it's going to be, if I just scroll back up, it is ECD I'm looking at here, and we've got 2 and x there. Now actually what I'm going to do is I am going to put these triangles back down here, and I'm going to label them. So this was E, this was C, this was D. And we want to work out the area of this larger triangle. Now remember the scale factor, the length scale factor from this triangle to this triangle was 6 over x. Okay, now this was 2, and this is what we've just worked out. This was x. So this is going to be 2 root 3. Okay. So I'm going to work out the area of the smaller triangle, and then I'm going to use the scale factor, the area scale factor, to scale that up to work out the area of the bigger triangle. Now, obviously, there are different ways you can do it from this point, because we could use Pythagoras with this one, with the 2x here, to work out this length, and then do it that way as well, because obviously 2 lots of x was the hypotenuse, so that would be 4 root 3, and then one of the sides here was 6. So it doesn't really matter which one is 6, but I think it wasn't that one, was it? It was the bottom one. So this side down here I had labelled as 6. So we could do it that way and use Pythagoras and work out this height, and then work out the area of the triangle that way, as I say. But what I'm going to do, because it's a bit more interesting and I like similar shapes, I'm going to work out the area of this one. So that's going to be 2 times by 2 root 3, and then I'm going to half it, and that's going to cancel out this 2 here. So the area of this triangle is 2 root 3. So the area scale factor is 6 over x, the length scale factor, squared, which is going to be 36 over x squared. Now, x squared was 12, and so what we get here is 36 over 12, which gives me 3. So to get from the areas, from the smaller area to the larger area, I need to times by 3. 2 root 3 times by 3 gives me 6 root 3, which is my answer. Units squared, if you want to include that. Units squared. Okay, I hope you enjoyed that problem, and if you did, or if you had a different solution which doesn't involve similar shapes, share it down in the comments below. It's been great to have you watching the video this week. See you in the next one. Bye-bye.